All right, guys, let's get started. All right, so today we've got two things we're doing, right? We're finishing the substitution cipher. That's homework that's due tonight, soft deadline and then hard deadline. On the weekend, I'll create that link and then we'll finish up the XOR hash algorithm. Okay. And yeah, so you guys will be responsible for encrypting something, creating the hash and everything, and we'll go over those problems again. Yeah, sure. Which one? XOR hash is something we're doing now, so it would be due a week from today. The substitution cipher, soft deadline is tonight, and the hard deadline is Sunday. Yeah, I'm about to do that. I know I haven't done it.
This got confused when it comes to those two, although you're just like messing up those two together for the assignment that's due tonight.
No, it's two assignments actually. So one substitution cipher, just that one program.
Yeah.
That's due tonight and Sunday, right?
Yeah.
You have until Sunday. And then I'll do that first today. And then I'll create two videos. How about that? So you'll, look at one, that's one homework, look at the other one, that's another homework. Don't confuse.
Perfect.
All right. And then, but yeah, I mean, I know it's similar, but you got to get, understand that these are different algorithms, right? Okay. And then I'll do the XOR. We should finish that one today as well. And then, yeah, that's kind of the plan. So it's week 3, this currently week 3. So I remind you that on week 6, we will have our first exam or thereabouts. It could be maybe a week before, a week after, but so start studying. All right, the exam will be closed notes, but you're allowed a cheat sheet, 10 questions or problems or something. So 10 items, could be code, could be explain, could be, what is. Does that make sense? All right, so start studying for that. Any questions? Yeah, sir.
Is it paper or
It's on computer, so it's like a Word document. So you'll have to download it, answer the questions, and then upload it. Yeah. But you can but I guess it's like paper, but electronic. All right. Yeah, so that's a good question. So let's go ahead. So as you can see here, you guys have completed secret key encryption. So that was, you had until Sunday. So I'll start grading this Friday. And you'll start seeing grades for that. Let's take a look at Python substitution cipher. So this is the homework. I'll just kind of go over the ideas again. Submit a report showing evidence that you completed this Python substitution cipher as discussed in class. You need to run it without errors and show evidence of encrypting and decrypting something, right? So I think I did the encryption part, and today I'll cover the decryption, but you need to make sure that this runs and provide enough screenshots showing evidence that you got it to work. Got it? All right, so we'll do this. Let me add the link. This will be due, as I said, tonight, but you have until Sunday. All right, so here. Okay, so it's due tonight at 10. Right, it'll stay open until Sunday the 8th. So that's really and then, you have to submit it by then. Okay, so complete the substitution Cipher problem thus covered. Does this make sense? Do you guys need me to say more about it? Show evidence, everything, all that. It's clear, right? Clear now. All right. Okay. I would link the video, but obviously I haven't created it yet. All right, so that's now done. So you guys, if you've completed, like some of you may have done the decryption on your own, and good, right? You should. But I'll cover it today as we are kind of transitioning. As we start moving throughout the semester, I will start doing less, right? And you guys will start doing more. So, but here, yeah, I will cover this one. All right, so I'll start shortly with this one, and then let's take a look at the other one, because this won't take the whole class, right? So this should take 30 minutes at most, I think. All right, and then this is the Python XOR hash algorithm. So we're talking about integrity, although this algorithm is going to extend to confidentiality as we start moving forward. I believe we did creating a list of blocks, right? And we were at padding, so we'll pick up there. Python XOR hash. Let's take a look at the document as well. All right, so here, submit a report showing evidence that you completed the Python XOR hash cipher as discussed in class. You need to run it without errors and show evidence of calculating a hash. Okay, so that's basically the example. I just want to do one problem for this assignment. Later on next week, you'll have the opportunity to work with your classmate and basically, do the whole sending of information, right? So sometimes we cover algorithms specifically, sometimes we cover more usage. So you have to get into the habit of it. So we'll come back to integrity for sure next week. All right. Yeah, so that's basically it. So let me create the link for this one as well. This, of course, is due 1 week from today. Okay, so we can do that. Assignment. This is XOR hash. Okay, so that should mean that, that's all you need to understand what this is about. And as I said, today's the 5th, so it's due on the 12th at 10. It's open now, and it'll stay open until the 15th. Okay, so that's really the final opportunity to submit. Okay, so complete the XOR hash algorithm. Class C attached Word document. Okay, clear enough? All right, so I'll create this link. So this link should also be live. All right, there we go. And so now let's go ahead and take a look at algorithms themselves. So I'm going to close these two. All right, I'm going to go in. We're going to start the virtual machine. Okay. Started. Right. Okay, so we've got our machine. As I said, this is the substitution problem. I'll go over the idea briefly, like summarize it, summarize the discussion on the encryption, and then we're going to work our way back to the decryption. And you guys, those of you that have solved this, can help me out to get to the solution, right? So gonna navigate to the desktop. Okay. Go. And then I'm gonna go into ITS 350. All. Make it clear. Okay. Let's -L. So we have to find this file. So substitution cipher. Let's play it. Okay, so I'm in that folder. /L, and it's probably this script, right? So open up nano here. Cipher.py. So I'll just kind of summarize the logic of this, right? So we are basically using the ASCII table, reference back to previous lecture. Basically, we want to encrypt, it's a substitution, so not a very secure cipher actually, but just to illustrate and get started how these things could work. So you take, we're just using the alphabet A through Z. So we want A's to be 26, B to be 25, all the way to C, Z being 0, 1. So basically the numbers are in reverse. We know that on the ASCII table, the numbers go actually in ascending order. So we did a trick, right, to kind of take advantage of that. And that way, by using that, you can convince yourself that you can actually add numbers, other symbols, and it'll work, right? Anything that's covered in the ASCII table. So we'll go over the logic again. So we usually start with some kind of a plain text. Today is Thursday. I'm in Hammond. This is going to be our cipher. So we define a function, encrypt, and this will be usually how we're going to do things. You saw me in the other example. I started adding other functions like generate keys, for instance. But in this case, we don't need a key. So we just have logic. So we encrypt the plain text message that produces a cipher, and then we print it. And then the next step is to decrypt and obtain the original plain text message, right? So that's where we want to be. So as you can see, decrypt is not complete yet. So this is what we're going to work through today as our discussion, part of our discussion. But let's kind of summarize what we've completed as far as encryption. So that's the whole thing. So I'll repeat. So I have in my encrypt function, it takes in the plain text message. I'm going to use this variable SS to hold the encrypted cipher, basically. I'm using numbers, pure numbers, and it's 2 digits per letter. So if it's 26, that's 2 digits. If it's 1 or 2, then it becomes 0, 2. And that way we just make it easier. So obviously we're adding all these patterns. So we've already established that this is probably not a good cipher. I'm only handling lowercase here, but it should work for any case if you're using the ASCII table approach. So here I convert the text to lower, then we're just we count how many characters are in the list. So it's effectively treating a sentence or a string basically as an array that we can index through. So I'm going to say for I in range length text, okay? And then I start iterating through text by index and obtaining the letter. Then once I have the letter, I go through this function ORD. This is effectively like looking at the ASCII table and like grabbing a value. So as you can see, I get N, that becomes a number. And then we establish this logic, which is the whole idea of it's in reverse and so on. We need to know that, what is the offset also in the ASCII table, right? So what point does the letter A begin in the ASCII? I think it was 97, if I remember correctly. All right, and there's maybe other ways of doing this, but this is the approach we're discussing. And then that's it. Once you do this, this gives you now the number. So A would be maybe 97 here. And then through this little function, which has a very obvious pattern, and therefore it is a bad cipher, actually, we get the code that we want. So A would become 26. But for some letters like Z, it might be 1. So we want all encoded values to be 2 digits. So that's what this little if statement does. So if something is less than 10 as an integer, make it string and add a 0 to it. If not, we take the 2 numbers and convert them into a letter, and then we just concatenate it basically, and that's it, right? So we had done this. This should work. We return, of course, SS. So I'm going to go ahead and run this one. I'm going to change the sentence a little bit so to show that this should work. Today is Thursday, and I am in Hammond, Indiana. Okay. All right, so there we go. So now let's go ahead, Control-X-Y. I'm going to run Python 3 as you guys have it. And there you go. That's your encrypted cipher, right? So all of you should have this. You need to provide a screenshot of this. Now we need to decrypt, okay? So that's the next step. So I'm going to go ahead. And this is the part I haven't done, so we have to think about how we're going to do this. So now we are going to enable decrypt. Decrypt will take, for convenience, we're just going to use our own cipher here. Although you guys could use this to communicate. I mean, it'll hide the information for a while, but eventually this would be broken. Okay, so then, I have decrypt, cipher comes in, and then I would get the new plane which gets printed out. All right, so I'm going to do decrypt here. Cipher. Here. So let's just say cipher. Okay. And we're going to return something. So in this case, let's return, we're going to need to have the decrypted, right? So let's think about this one. This will be a string. Let's just use SS, I guess. Okay. All right. So let's think about what we're getting. So we're getting the number, right? So we're getting cipher, the string cipher, right? We know that we need to grab every 2 digits this time around and convert that. So, how do we do that? Okay. All right. So again, there's a lot of ways of solving this. Okay. I'm just doing a very obvious one, but there could be more efficient, ways of doing it. So I'm going to use a little counter. All right. And so this counter, I'm just going to count every 2. All right. Python is very powerful. So there are other, and I'm sure you guys can think of, more clever ways of doing this. I'm just going to use a little counter, right? And so I'm going to grab every 2 and I'm going to slice it out every 2. All right. So I'm calling it YY. That's going to be my counter. So I need to iterate for sure, right? So now, even though that string is a string of numbers, they look like numbers. It is effectively a string. So we got to treat it the same way that we did before. So I'm going to do for I in range there. Okay. So for I in range, and then we're going to say length of cipher. Okay, so that's basically what we're doing. We're measuring the length of cipher, and then that way we know how to iterate through it, right? But remember, we have to grab 2 items instead of just 1. So then we have to think about that. So 1, 2, 3, 4. So I'm going to create a temporary variable here. I'm going to call it foo. And basically, this is to grab these two-digit pieces of the string, these 2-digit slices. All right, so I'm going to say here, foo equal foo plus cipher I, right? So cipher I. Okay, every time we do that, we're gonna check to see if the counter is 1. If the counter is 1, it means we've grabbed 2, right? And then we have to take action. Otherwise, maybe we just increment the counter, right? So something like that. All right, so let's see how this works. So I'm going to do if YY equal 1. Okay, it's currently the first time it would be 0. So it wouldn't do anything. So let's just say here 1, 2, 3, 4. I'm going to add a comment there. Now I'm going to go to the else part. Else. So if YY is not 1, it basically means that it's 0 because we only have those 2 options. So all we do then is probably increment the counter. So 1, 2, 3, 4. YY equal YY plus 1. Does that make sense, guys? What I'm doing here? And as I said, there are way better solutions. But anyway. All right, so now in the event that it is 1, what do we have to do? First thing we want to do is make YY equal 0, right? Because we're going to start the next 2 and the next 2 and the next 2 and the next 2 and so on. Any questions on this idea? Pretty simple, right? Okay, great. So now that I've done that, then basically all the hard part is done, I think. Everything else that remains should be pretty straightforward. What do we want to do? We want to convert foo into an int. So foo, I'm going to call it foo int equals int foo. Do you guys see that? So I'm just making it an integer because now I definitely want to convert it back. So before I forget, foo needs to be reset to what? I'm going to use double quotes to be consistent. Remember that we use foo just to grab every 2, right? So once I grab the 2, once I converted it to int, I reset it to nothing so that I can grab the next 2 and so on. You guys see that? So that's basically it. Okay. And then now, just like we had a function that would convert a number or our letters, sorry, to the ASCII number, we have the opposite of that, right? So this would be a number back to the ASCII letter, and that is called CHR. So the CHR function will take, and let me do this. I'm going to make code equal foo int. Okay. And then now CHR takes code and returns S code, right? So basically it takes the number 26, you know, let's say if it was 26, it would return what? The letter A or something. You guys see that? So that's the basic idea. And then once I have S code, then that is the letter, and we need to start appending it to our result, which in this case is SS. So SS, concatenate it with S code, and that's it. Do you guys see what I'm doing? Any questions? Any questions? Everyone? Anyone? Nothing? All right. So let's try it, right? That's the way that we know if things work. So let's go ahead and try it. All right, so Control X, Y enter. So that definitely does not look like a string, right? No errors though, right? So what are we missing? Are we missing something? Well, since we don't know, maybe we need to debug, right? So let's print code and see what's going on. Okay, we're going to print code. These are the numbers, right? And see what happens. There's a bunch of numbers in there. So 26. 7 and 12 and 81. I don't think I'm missing anything as far as the logic. I mean, there's one thing I'm missing, obviously, but I think this is correct. All right, so it printed numbers. It gave us some strange characters here, which is probably, it converted to some numbers that are not represented as Unicodes, right? And that's why we're seeing this. So it's interpreting them as ASCII codes, maybe, or sorry, as Unicodes instead of ASCII. All right, so obviously what we need to add in here is the logic, right? So we did this logic, right? And we need to, it's currently A26, right? And whatever, B25, but in the ASCII table, A is not 26, right? It's 97 or something. So we need to reverse the logic of this function. Do you guys see that? Does that make sense? Yeah. All right. So who can tell me how we do that? So I added this line of code here, code intentionally, right? So that's where we can do this. So any ideas on how to reverse it? Oh, no, just stretching. Huh? So 97 here? You tell me. Okay. So 97 plus this one. Okay, so let's say it was A, right? So A was 26. So we need to make it 97. How do we do that? Similar, right? So I'm just trying something. So if A is 97 in the ASCII table and it's currently 26, then what if I just do 26 minus this? 26 minus 26 is 0, leaving us 97. right? Do you guys see that? Do you think that'll work? Yeah, let's try it, right? So that's what we should do so we can try it out. Any questions on that? Doesn't work?
Doesn't work for me. Unless I'm missing something.
Okay, let's run it, so I haven't really. Let's take a look. It worked, right? So this time it worked. So I'll show the code, of course. But I think it worked. Do you guys agree? I mean, you got your message, right? Today is Thursday, and I'm in Hammond, Indiana. That was the original message. So there you go. And you did the little cipher there. So I'm gonna remove the print statement because I don't need that anymore. So this print statement does not need to be there. But yeah, does that make sense? Any questions? That's your homework. Substitution, this was your first algorithm. It's the only insecure algorithm we'll cover in this class, I think. All right, so everything else after this should be more secure, because it's going to be based on actual the main principles or primitives of modern cryptography. But this would be before, right? So do you guys see that? Have you guys seen a movie called the something game, the Enigma game, or what's that movie? What is it? The Imitation Game. Have you guys seen that? It's about the Second World War and how Turing, Alan Turing, he was, very famous and in computer science. He broke with his team the Enigma machine of the Nazis during the Second World War. So that was not based on modern cryptography, right? That was actually based more on these types of algorithms. It's more like older. You see that, guys? If you want to see that machine, I think it's going to be here tomorrow. Did anyone get that information? Tomorrow at 1. So if you go see that movie tonight, but you could see that movie tonight, know what it is, and it was the Nazi machine for cryptography. So they were sending all of their encrypted messages for the war, and then the England, right? So they put together a team led by Alan Turing, who is like a genius, right? Did the Turing test and a whole bunch of other things. So they broke that machine because it had patterns. It wasn't like a very secure thing. And so tomorrow at 1 o'clock, do you know where? CLO 190. Where is that? CLO. What is that? Classroom one? Yes. By the cafeteria? Yeah. So CLO 190. There's this gentleman from the NSA. I forget his name, but he's going to be here tomorrow on campus, and he comes every year, and he brings, I guess the NSA has a real Enigma machine, so he'll show it. They'll also talk about jobs at the NSA. If you're interested, you can tell them that you're taking cryptography and you want to go do it. All right. So anyway, thanks for letting me know, because I didn't know. Any question? Oh, sorry, you had a question. Yeah, of course. All right. Which part? The decrypt part? Okay. Was that error before we started coding this? This is all we've done today, right? Huh? Higher up? Any other questions, guys? So that concludes this example, right? We did it, right? We encrypted and decrypted something. I'm gonna end this video so that you don't confuse the topics, and then I'm gonna start a new one where we're gonna do the XOR hash algorithm and so on. Any questions? Everyone good? Yeah, sure. Yeah. Guys, any questions? Everything clear? All right, so I'm good. Perfect. Thank you. All right, so I'm going to end this one, start a new one. Okay.